Question number 10. Two objects move towards each other along the same straight line. Definitely they will collide. Okay. After colliding, the two objects stick together. Stick together. Okay. That means what kind of collision? Inelastic collision. Inelastic. When there's an inelastic collision, what happens? The kinetic energy is not conserved. Is not conserved. What about the momentum? Momentum is always applicable. Whether it's elastic or inelastic, it's applicable. Okay. Let us read the option. Which statement must be true? Total kinetic energy of the two objects does not change with the collision. No, kinetic energy is lost. So therefore, this is not true. Okay. So then, the total momentum of the two objects before the collision is 0. This is definitely right. See, many of us think, how can it be 0? It is moving, right? Let me write down the equation so you get it correctly. Let m₁ be the mass of this object. Let v₂ be the velocity of this object. This one, let the m₂ be the mass of this object and u₂ be the velocity of this object, speed of this object. So what is the momentum before collision? Total momentum before collision is nothing but m₁u₁ minus m₂u₂, minus m2 because it's going in the opposite direction. Okay. Now what is the total momentum after collision? After collision, it says that both the objects are stationary, they do not move, but they stick together. When you say stick together, the total mass is m1 plus m2 and the total velocity. What is the velocity of this object? They are being stationary. It is like you take two chapati balls, two flour balls and then hit it together. So these two comes together, hit together and they are just stationary there itself, right? It's not moving anywhere. So this means its velocity is 0 and thus you see the total momenta before collision is equal to total momenta after collision. Total momenta before collision is equal to 0, right? So it's total momenta. I am not talking about the individual momenta. Total momenta is 0. So that's what is being given here. So this option B is right. The two objects should have equal mass, not actually two objects will have the same speed before the collision. Not necessarily. I have to choose two different speeds over here, right? So B is the right answer.